Okay, so a few things that I wanted to go over. One thing is exporting from Rhino. Hopefully you guys got to the point where you have this all subdivided, and we can review some of that if you'd like in terms of the Boolean split and so forth. The other thing, once you have created, and this is another idea, I guess, if you sort of created your topography without the use of contours, maybe you just kind of manually created these surfaces and wanted to just work through topography that way. It's very, very easy to get contours out of that form. So I'm going to show you, and this is pretty valuable for a lot of different things. In particular, there are two steps to the exercise, or two parts, I guess, to the exercise I'm asking you to work with. One is the larger base, is what you're seeing down here. And that one I'm asking just to be a fairly typical stacked topography, right? And then there's the second one that I'm asking you to then filter through 123D Make, and we'll review some of that again here. But in terms of this one, sometimes maybe you want to change material, or sometimes you may want to just think about the contour in a different way. Again, maybe kind of working just with the model itself as opposed to anything else, other Boolean splits, other sort of manipulations like that. There's a really great tool here. It's under Curve, and particularly Curve from Objects. Now, Curve from Objects, there's a whole set of things that you can do with Curve from Objects. There's all different kinds of ways you can extract curves from any given object. The one I'll show you right now is called Contour. So I'm just going to select that. I already have the polysurface selected. And it's asking me for some input here. So the ones that you should note is contour base plane point. So basically I'm going to select a point at the base of this polysurface. Direction perpendicular to the contour plane. So we want to know in what direction do you want these to stack. I could stack them laterally. In this case I'm going to stack them or stack them vertically but horizontal slices. So I'm just going to click on this edge. Now it's asking me for the distance. So if you were using a thicker cardboard, maybe it's 2 feet. If you're using a thin chipboard, maybe it's 1 foot, right? So here's where you can start to make some modifications based off of the model material that you know you're going to be using. I'm going to keep the default as 1 foot, and I'll just hit enter, and it creates all the slices. So, right, so now I have a whole set of slices through that object. Those are independent curves, so what that I'm able to do, so I'm just going to move those, go to my top view so I can see what just happened. Now I have all the individual slices that are through there. Then what I would be able to do is take each one of these, and I believe it automatically groups them by elevation. I can take each one of these slices and move them over so then I can lay them out to be cut somehow. Either you want to print it out on a sheet of paper and use it as a template to cut, or if you want to use the laser cutter. So then it would be a process of moving some of these out. And I'm just dragging, I'm not even using the move tool. Obviously you want to make sure you remember what each of these are. I mean, you have the model for reference here, but you want to remember what height each of these slices are. So you may actually want to keep this as a resource here, or kind of a backup, and then do copies. So I'll just go copy and move those down. You could also just write a little bit of text right by it. Just use the text tool here and say that that was, I forget what the overall dimensions are. 1,004 foot elevation. I could just put that there, and then when I transfer it into the AutoCAD file, I can actually just etch this right onto the sheet, and so then the number's right there. I know what level it's at. I know what comes next after that. So that's a pretty handy tool. Okay, so the other thing I wanted to talk about, just to clear this up, I think the file that I uploaded to BBLearn had this bird's eye -2 instead of perspective. What that is, if I down click this pullout here by the viewport, really what that is, it's a named view that I had, was still in the file, that was just a residual, so it actually is not even saved here, but the viewport was called that, even though it wasn't saved. So it'd be just as easy as set view, named views, and if I hit save, this is a view I really wanted to keep. I can call this whatever I want, bird's eye 2. So now that's saved. So then no matter what other view I'm in, I can go down here and click set view, bird's eye 2. It's going to bring me back to that view. Now if I just wanted the default is, it will just be called perspective. And depending on the perspective view, again, you can start to use this to set up other drawings and what have you, even if it's just a screenshot that you print out. What I tend to do is I lean heavily on changing the lens length depending on what it is I'm trying to depict. If I'm really trying to get into a space, I'll use the 17. It's a bit of a wider view, so I can really kind of get into the space. If it's a little bit more overall, like an axonometric, I'll kind of stiffen it up with something like the 50. But you can see the differences. Okay. So the other thing was exporting. So I showed you how to do that. So you can make those stacks in a variety of ways. You may already have the contours, and so you just can use those lines as well. You don't have to use this curve from objects, but I wanted you to know that that tool is there. So I'm going to make this selection, and probably could just type in export. I guess I usually go under File, and I'm going to go to Export Selected. And for this to translate into 123D Make, it needs to be an STL file. So I'll go to STL, and then I'll save it accordingly. Give it a name, and I can go back and put it in a proper location. So STL files is what you really want. You know, sometimes with naming files, what I tend to do a lot in my own work is to start off with a date. So if I want to create another version, the drawing may be called the same thing, you know, topography 2 or what have you, but the date is different, and that date is telling me if it's newer or older. In order for things to kind of line up well in terms of date, and this is a convention that I came to use coming out of practice, you actually start with the year. So I would start with 1509, and today is the 8th. Then dash topo 2 or whatever you wanted to call that. So that way when it comes up in the folder, it's going to be sequential by date. I believe that's one of the defaults, or at least you could set it to that in the Explorer folder. So then you can find the newest one quickly and so forth. I'm going to cancel out of this because I already have that file exported. And I'm just going to start up a new 123D Make file. I'm just typing in 123D Make here. So we can walk through these steps. I know I went through this pretty quick. And what I want you guys to be able to do today is get to the point where you are bringing that STL file, that part of the model, into 123D Make, and starting to work with those parameters and set up the file that will then go into AutoCAD. I'll show you the preliminary steps to go into AutoCAD. There aren't many, there are a few, but that's what Jay is going to be looking for. So we'll be using the template file that's available to you on BBLearn, and also just a quick method to get that information on that template file and have it be on the appropriate layer with the appropriate line widths. All of that the last part in terms of getting it on the layer, and the line width is just one command. So it'll go quick. So import. So I'm going to bring that file in, and it's already navigated to the previous export that I had made. And I'll say open. Okay, so we have the file brought in, we have the model brought in. Now the scale isn't quite right? Because this says the length is 8 inches, and it's going to take that long length there. But I don't think that is coincides with the actual scale. So one thing that you can do pretty quickly, if you still have your Rhino open, or go ahead and open it, is just do a measurement. I'm just going to type in distance, DIST is enough to get that command. First point, second point, it's giving me 98 feet, 8.5 inches. So whatever that is, whatever the overall feet is, and you can convert it if you like all to inches, but basically what you want to do is divide that by the factor that you are scaling. So if it's a 1/4 inch or 1/8 inch, this is going to be 1/8 inch that you guys are working on, so I would divide that by 8. And so if I do that and factor the decimal for the inches there, I'm going to get, I believe it's about 12 1/3, 12.33, something like that. If I was going to do a 1/4 inch, I'll divide it by 4. The idea is that for every inch there are 4 feet, so if I divide by that factor, I'm going to get the number of inches, right? So then I'll just come down here to length, and I'll type in my 12.33, I believe that is correct. And right now it's set to uniform, so it's going to keep proportion. I'll just hit tab, and it'll think a little bit, and it's going to rescale that appropriately. So it should be really accurate in terms of the scale. And now we're dealing one-to-one with your model scale. The next thing to do is to set the material. This is very similar to like setting up a printer or a sheet that you're going to print on 11 by 17 or what have you. The difference is we also have to deal with thickness, right? So I have one here that's already set up that I use for chipboard. But I'll show you how to set up another one. You guys probably won't have this. I'm just going to click on that little pencil tool, and then what you're able to do here with these pluses is if I hit plus, I could create a new material for use here. So in terms of the name, you know, I can double click on it and give it whatever name I want. Make sure I'm in the right units, inches, and then I go ahead and describe the sheet good, right? I say 18 by 32 because that's one of the dimensions that we can use down in laser cutters. So you'd have to trim down your chipboard for that. The thickness is about a 1/16, but you have to, you know, be careful. You know, some of the chipboard you may be getting has varying thicknesses. I know they have varying thicknesses at the bookstore. 1/16 is, you know, tends to be somewhat close, but this is important because once we start to interlock these, those slots are going to be based off of that thickness. The margins I usually don't play with, and Tucker or Landon, do you guys?
Jay usually wants a 1/4 inch margin.
Jay wants a 1/4 inch margin, so it's set to 1/4 inch already, 0.25. So yeah, Jay doesn't want the laser cutter going to the extreme edges. He wants it sort of enclosed, so a 1/4 inch there. Slot offset, basically that's a bit of tolerance between the slots, and so if it's really super tight, it may be actually difficult for those pieces to fit together. That bench, and this is the model for that bench that's in the red room, that was part of a seminar last semester, and those tolerances were very, very tight, right? It was a bit of a challenge to wrangle some of those pieces together, not all of them. So that's something to tweak. You're not going to have to really deal with that so much with chipboard. You know, it's pliable enough. So I'll leave that as the default. Then you can just hit done. I'm not going to do that though because I already basically have that set up. Okay, so our material is set up. The scale of the model is appropriate. Now the trick is to select a technique for construction. What I'd like you to do for this exercise is use the interlock planes. When you make those selections, be careful that your material setting doesn't change. Sometimes it has the tendency to jump to something else, so you want to make sure that you have the right material selected. Okay, so immediately we see it translated that model into a series of interlocking slices, and we also see here a quick setup for how the layout pieces, or the actual pieces to be cut, will look. I'm going to minimize that. And, this is, so we have a couple floating pieces. That's probably not going to work. But also it's just a little bit sparse, right? So if we go down to slice distribution, the method here is by count. You can do it by distance, but I'm going to keep it by count so I can just control the number of slices. The first axis here, I'm just going to type in 20 to see what happens. So that's the horizontally stacking one. That may be a bit much. Maybe I'll pull that off to 12. And maybe I'll increase the vertical slices to about 15. Something like that. So play around with that. You want it to be, substantial enough to where you're able to read the topography, but at the same time, I'm asking you to do this so you can now use this as a way to rethink what topography really is, right? We've been dealing with it as a series of stacked planes. If we interpret it another way, using a tool like this, it presents other opportunities that we may not have seen before. That's why I asked you guys to do sketch models or think about structure, use the infinite strip, all of that stuff, so you start to see things a little bit differently and see other possibilities. So that's why I'm asking you to do this as well. In terms of the number of slices, I don't have one that, a predetermined one for you guys. Play around with that. You can see here we still have a floater. I don't know if I'd really worry about that little sliver there necessarily. So again, play around with it. If it starts to get a little crazy, maybe it gets a little bit crazy. The other thing about this, let's see, what you're able to do, if I go down here and select slice direction, see we have now these selectors. And so what you're able to do is drag these around. Now this is I would almost call this a kind of beta program from Autodesk. And so it's not like as precise as it probably should be, but it's enough where you can start to see the possibilities of using a tool like this. I think this is something they'll continue to develop. And so once you start playing around with these slices and the angularity of it, it's really hard to get back to ground zero, just these straight verticals and horizontals. So you want to be careful of that, or at least if you start goofing around with it, realize you may just need to start fresh, bring that model back in, and start with simple horizontal and verticals. But what you're able to do in real time is just grab onto these, I guess that's kind of an arrow there, and I could just start to change the orientation of those slices. They're still perpendicular to each other, but they're no longer perfectly horizontal or vertical. So I can change that in a variety of directions. Again, as an opportunity to really think about topography, the site, as it's related to design in some different ways. You'll notice that there are some of these red sections. And I've done a few of these, and there always tends to be some errors. Basically what this is saying is that there may be some issue with you fitting these pieces together. Like the red ones you may need to break in half, get them together, mend them back so it's a whole piece. And so it's not perfect. But we start to get the idea, we start to get the understanding of just different ways to think about modeling. So that's something when you change these direction of the slices and so forth, you're going to see some more or less of these problems here. Landon, do you remember with this bench, did you guys come across a lot of errors like that? Just kind of work through them? Yeah.
With chipboard, it's not already being invented.
Yeah.
You really need to.
MDF, it was a little something else. Okay, so that's one thing that you can do. Creating a different kind of dynamic there. Modify form. The one that's kind of interesting, I don't expect you to use this for this model. I don't know that it necessarily makes sense because it is topography, although if you want to use it, you can, is hollow. So if I wanted 123D Make to think about the volume that I brought in as having a hollow core, I can do that. So I can make this selection and see this little corner that's torn away. It's out of the view there. There we go. And all of a sudden, it basically gives us a tearaway so we can look inside of that volume, and then we can start to see those lines really start to say, this is how deep, the thickness of the poly surface is going to be, and the rest of it would be hollow. And I could use this slider to increase or decrease that. So you see it gets very thin along the wall there. These lines get thinner. Really get thick. I'm not going to do that for this. Okay. So it is, yeah, it's not hollow, so I didn't apply that. I think if I go back to this, I think it's falling off the screen. There's an apply button. So once you toggle it here, you have to make sure you hit that apply button, and then it'll make the change to the model. Again, the piece of software isn't perfect, but it works for what we're trying to do here. All right, so one of the things that you can do then is where it says here, get plans. That's what you kind of need to translate this to the laser cutter. So I'm going to hit this little sheet, this little button. Right away, it's giving me a layout based off of the sheet good that I already created. Right, I already said it was 18 by 32. So it took all these pieces and laid them out. Right now, and then we have 2 overall sheets. Right now, it's under what's called simple. So if I drop down, I can ask it to be nested, and what that means, basically, it's going to try the best it can to compartmentalize, to push these pieces as close together so you're not wasting material, right? And I guess I got it on one sheet there. Whoops. So now we just got it all on one sheet. So that's a little bit better, maybe a little bit more usable for what we're doing. And then I would go into export. Now I don't want to export an EPS, and you can, if you're savvy enough, you can play around with different file types. Seems to me the most direct route for what we'd be using here with the shop is a DXF to get it into AutoCAD, and then I would type in export. You notice the inches is selected already as well, so it should come in 1:1 model scale through that DXF file. Yes, question.
Typically, how long does that take on the laser type?
This, geez, I don't think that would take very long. There's not much etching on it, just the numbers. I would say, I don't know, half hour? Not even?
Maybe even less than that.
15 minutes? It's a little bit because it's kind of first come, first serve in the shop, and so, and then Jay or whoever is there may do some modifications, some slight modifications to the files, or at least set them up. So that takes a little bit of time, but this is pretty simple. It would go pretty quick, and it's thin material too. So then I would hit export. It's because I'm not signed in that's giving me problems, and I have internet issues here. But basically what you're able to do is just export that. You want to export it to your computer, put it somewhere, give it an appropriate name, and then you'll have that DXF file. Okay, so I just opened up a fresh AutoCAD file. I already had it preloaded because it takes just a little bit. And this file is actually the template file that I provided to you all on BB Learn. So it's a little bit hard, but you can see here, laser cut template file. And what's important about this is that it has all the right layers with all the correct line thicknesses, which is just 0. And the different colors are associated with different kinds of cuts already preset. So you need to bring the drawing through this. And we'll show you how to do that. Let's see here. Here's a DXF file that I had made previously. So I'll just double click that, and it should, the default here is AutoCAD, so it should launch it. If not, you can always go through Open within AutoCAD, or right click on that file, choose Program to open, and select AutoCAD. So now here are all the files, or the cuts here. You notice it's a little bit wonky in terms of the view. I know that's kind of hard to see. So I'm just going to do a quick, I'm just going to type in Z, enter, and then E, enter for extents. So that'll give me the zoom to extents or whatever is there. Now basically what I'm going to do, remember the selections here are very similar to Rhino. So if I drag to the left, you see I have that dashed line. So whatever intersects that line, it's going to select it. Didn't get that bottom line. Now I don't have a command launched right now. I'm just making the selection. I could zoom out and just drag a window and grab it that way as well. So all I'm going to do here is hold down Control C for copy. Right? And this is a different file. Now this is nested layout 0. This is a different file than the template file. And I would also be careful to save this as something else, so you don't, if you have that template file, you want to keep that fresh and not with this other line work on it. So all I'm going to do now is type, just hold down Control V for paste. And it typically, and it might be hard to see depending on how the scale is working here, but typically with a copy paste like that, or bringing in a block, it's going to choose the lower left hand corner, whatever the object is. So I'm just going to type in 0, 0 to keep that close to the origin. And then I'm going to type in Z, enter, A, enter for zoom all. I can see a little bit right there. Z, enter, E, enter for extents, and there it is. Okay, so now it's on its own layer. You can see these came up with their own layer here. So that's added now to this file. So, and you can see what these files are. So raster engraving deep, you're not going to be using that one. Raster engraving light, you may use that for the text, so you get the text etched on each piece. Vector cutting, perimeter cuts, basically if you had an overall cut and then cuts within that cut, that's what it's talking about. So it would make the, I forget what is the internal cuts first and then the outer, so the pieces stay in place while you're cutting them. So that matters, although all of our cuts are perimeters, right? And so it's all going to be on perimeter cuts, so it would be final perimeter cuts. Here it's interior cuts would be the objects within that may be there. Oh, actually, I take that back about the raster engraving light. You would use the vector engraving light. It's just straight lines, it's not an image. So I'm just going to select that. So I'm on that layer. I just pulled this down here and I just clicked on it, so now it's the current layer. And I'm just going to draw a line. I do a lot of type-ins, you know, similar to Rhino. You can just do type-ins. You can see line is right there. But I'm just going to type in L, enter for line. And now I'm going to do, you could do this in a few different ways. One way would just be to, we're going to use the tool match properties. So it's this big button right here. And what I'm going to do, it's going to ask me for the source object. You can see down here below in the command prompt. That's my source. So I want the vector engraving, so I want the numbers to be that. And now you see it has that little paintbrush on it. That means whatever I select now is going to have the same properties as that line. So I can make all these selections. This is going to take forever, right? So what I like to do, and you could do it that way if you need to. If you hold the scroll button down, that's your pan. Scroll back and forth, or moving the scroll wheel, zoom. What I'm going to do is I'm just going to isolate a couple layers, right? I know I'm not working with these blue lines right now, so I'm going to go into, right on top here there is a series of layer commands. You can freeze layers, turn layers off, make layers current, and so forth. I'm going to isolate. So I click on that, so whatever I click on now, it's going to isolate those layers and get rid of everything else. So I just have the numbers and that line. I can go back to my match properties, select this, drag a window. Now they're all on the right layer. So these are ready to go. I'm just going to select this and hit delete. And if I want to unisolate, it's the next button over, unisolate. So I have the blue lines back. I want those blue lines now, though, to be on the final perimeter cuts. So same thing, I'm going to draw a line. Just use L enter. I'm going to go back and isolate. And I'm going to use my match properties tools again. Drag a window, and now they're set up. I can go to unisolate and bring everything back. Looks like a little guy got missed there. We just want to inspect a little bit of these, or why these got cut, and just draw lines to connect all those. Oop, the snap is on. F3 to get rid of snap. Nope. Where's snap? There. Oh. Is it 9? There we go. F3 might be object snap. Yeah. So I'm just going to close these up. Oops. Control Z. Do you guys know, does Jay like these to be, the perimeters to be all like a polyline or joined?
I don't think he cares too much about the perimeter. Are you talking about
Each of these pieces, right now, each of these vectors is a separate line.
I don't think it matters too much.
Yeah, I don't think it matters. I usually do.
Yeah. It's just nice so you don't lose a part of the profile. What I'm talking about, as you can see, these are all fragmented into various lines. And so if I just make a big selection here, and I'm just going to type in join, I believe works here as well. Okay, and I go back in. Now all these are selected together. So it took those and joined them all together as a polyline. Just almost like, just to make sure things don't get messed up. You don't lose pieces. And then this is already set up, and you guys can fill me in. I haven't done as much laser cutting as you two. Basically, this is it to bring to Jay, right? You bring this file. So this whole thing would need to be rotated?
Yeah.
Okay.
Yeah, like that.
So to rotate, just type in rotate. And commands pop up similar to Rhino. So I'm just going to hit enter, make my selection. Ortho is on, so it's automatically going to do that. And then I'm just going to, again, I'm just going to move this. M, enter, or you can just type in move. Select this corner and bring it to 0, 0. It might matter when he's setting up the laser cutter file. You want to make sure that origin 0, 0 is one of these corners. I always err on that corner. So then you can save it and bring that on a thumb drive to the shop, and it should be ready to go. Again, you just may want to zoom around a little bit, make sure you didn't miss anything. Looks like this is an artifact from something else. That's probably something I would just get rid of. But you just want to make sure to get rid of and close up some of these pieces and zoom in and out, just make sure they're continuous perimeter cuts all the way around. So those are the basic steps here. You know, from that I would just go into, click on this icon, save as something, give it the date, you know, put it in an appropriate place, think about file management, and then go ahead and bring that over. And that's basically it. Let's see. Now that's most of what I wanted to cover. I wanted to leave the remainder of time for you guys to go through these steps. Coming out of Rhino into 123D make those adjustments, and try bringing it into AutoCAD as a DXF and make some of those changes. Maybe you just kind of go through that process quickly, you know, in terms of 123D Make. You can always tweak that later, but play around with those settings, and I want to make sure everyone gets through that workflow loop before you leave today. Question?
Yeah, so when I was working on editing my curves at home and stuff, like I managed to move all my curves up to the appropriate elevation to make the loft thing, and I'm not really sure where to go from there to like cut out that 144 section and stuff, so I didn't get anywhere near this far.
So do you have a poly surface? You had that overall model, right?
Yeah.
Okay. And then, well, why don't we work with you individually? I think it probably makes more sense. Unless there's something like a command overall you wanted me to go over here. What would you like me to go over here in Rhino?
So right now she just has the surface, so she actually needs to do the shape, so.
So just the surface on the top.
Yeah, just a simple surface, so she
Okay.
can take this.
Okay.
Should you go?
Yeah. Oh, I have topo there. Yeah. That's what I extracted. Okay. Okay, so basically from the contours, you want to know how to create the surface and make it into a poly surface. Is that right?
Yeah.
Okay, I'm going to close this. Let's see. I am going to make a trim. Okay. I'm just going to trim this surface out and then show you how to do it. So go trim. Oops. Control Z that. Enter. So you have this piece up here. Is that right?
That's where the whole thing is done like that, but, yeah.
You have a
Yeah,
contoured
I
surface.
just have a full surface, not just that one.
Okay, you have the contoured surface. So the trick is how to make it into a poly surface, yes? Okay.
Can you also maybe go back one more step and show how you selected that specific square? Because when I click on it, like that whole section is being selected. Does that make sense?
Yeah, I think so. This blue square?
Yes. Yeah.
Okay, so I tried to select it before. What happened is it was locked. So that's actually this site model 96, translating to 1/8 inch scale. It's that layer, and I just hit the padlock to unlock it. And now I can select it. So I selected it even before I went into any command. If I go into trim, it's going to assume that I want that object to be the cutting object. So then it's asking me select object to trim. So I'm just trimming everything else that's around it. And right click to enter. And I just pull this piece out.
How do you make the rectangle to trim?
It should already be there, and you can move that around. So if you need to move it, but it should be already in that file. That square should be already in the file. If not, to draw a rectangle, I'm going to select the rectangle tool here. I'm going to select a point to begin. So now I could drag whatever I want here, but I'm actually going to type in. So I'm going to go in, and I believe this should work. If I type in at, so that's going to say that origin, I already have 1 point selected. So it's from that point. Now I want to go somewhere else. 144 feet by 144 feet. So I'm just typing that stuff in. Then I have that square. Then I could just select this and move it around to trim wherever you need to trim. Or you can use the one that's there. Make sense, guys? Okay, so a few different things. I'm going to explode this. So to make this into a poly surface. One thing that you can do, there's a variety of ways to actually get it to be that. I gave you a base plane and everything here. I already trimmed it out, but there was a base plane and everything to help give it some thickness already. And so hopefully you're using that. And so that's why I set up this file, so you wouldn't have to necessarily go through all of this. But in any case, if you wanted to create the base, first of all, you want to know where 0, 0 is. And draw a line. So if I go into top view, I am just going to start drawing a line. Right now I'm going to attach it to this corner, or I'll use this lower corner. Even though that's up in space potentially, but I can always push that down to 0, 0. That's what I'm using as the base for the model. So same thing, I could click a distance here. I'm just going to type in 144 feet, because I know that that's the dimension. It's asking me to verify that. It went wrong. Try that again. And hit enter. Let's see, what layers am I on? I'm just going to change this to black so you guys can see it better. So I just drew that line. And so if this is 0, then you can use that. If it's not, and you're not sure where 0 is, I can go into top, and I'm going to project to construction plane, so that's under transform. That's going to project it down. I want to delete the input, so I'll select yes. So I'll push that down so I know it's at the base plane for the given height of the model. And it ends up being just a little bit lower than that, probably a couple feet. Now, to make the surface for the base plane, I could do a few different things. I could extrude this over, or I can, so I could just extrude that line over 144 feet. Again, I know that that's the distance, or whatever distance you're working with, you can verify that. I could copy this line over 144 feet and then loft those two. So there's a variety of things that you can do there. I will try to, let's see, I will go into the top. I'm going to go into surface. I'm going to extrude curve straight. See, now it's up and down. As its default, I should be able to toggle the direction. Select a direction. I want to go in this direction. So now it changed it from extruding it up. Now it's extruding it over. And then again, I'm just going to type in 144 feet. Now I have a base plane. So then what you're able to do, now I have the base, I have the top, I know where the corners are. I can go under my surface tools, and I think I'm going to use edge curves. I could use probably planar curves. Let's try edge curves. Select that top edge of that surface, the bottom edge, right click, have that thickness. I'll enter to repeat that command. Top, the bottom. This might get a little, well, that probably work. That got a little weird because that bottom line is way longer than this part of the surface, so I'd have to go in there, figure out where these intersect, draw a line. So that's just one of the object snaps is intersect. Grab that, go back to this corner. So now I have a line there. I can go back to surface, edge curves, top. I want to make sure I'm selecting that smaller line, enter. There we go. I'll repeat that process here, so I know I'm going to need a line. Enter. Edge curves. And then the last one here. Now one thing, I want to create this, make this into a poly surface. The one thing that's a little funky about this model is that we have this extra part of the base that's kind of scooting out. For the sake of like bringing it into 123D Make and everything, I would trim that out. So that's at 0, 0. And once I kind of bring it, it just might confuse things or confuse how it might become a poly surface. So I'm going to trim that. Go to my trim tool. I want to trim by this edge as the cutting edge. Let's see, it's not letting me do that. It should let me do that. Let's just try this as a cutting object. Right click. I want to trim that. It's gone. Okay. Now I'm just going to select everything that I just made. And I'm just going to type in join, or you could hit this puzzle piece icon over here, enter, and then it created that into a poly surface. So that's all one big solid essentially as far as Rhino's concerned. So from here I'd be able to place then the objects. I'll just bring in this one cube. Oops. I'm going to copy it over. Target that view. And then I could start doing the Boolean split or making those modifications. If you have contours and not a surface, so say you just had them on the right heights and everything, I know some of you already have this. I will show you. Just holding my shift key down to select all those layers so I can turn them all off. You can so you can do the lofting like I showed you before, right? Loft from one to the next. Surface, loft, select one curve, another curve, and you can build it up that way. So that'll get it to be a little bit more precise. Another thing that I just did on a project I'm working on right now, I think some of the topography, some of this gets kind of challenging. Even some of the surfaces start to fold over on themselves. So another command that you can use to do this is called a patch. So patch is a kind of surface, I believe. There it is. Patch. Select curves, points, clouds, and meshes to fit surface to. So I'm just going to select all those curves, hit enter. And then I'm going to have a dialog box in this preview. And actually this view is not good because I want to see what's happening three-dimensionally. So I'm going to cancel and go through that again. Surface, patch, select all of this, enter. And then I can hit the preview key. So it's going to take all those lines and start to interpret them in a way to create a surface. And you can start to then fine-tune the stiffness, fine-tune the UV or the X, Y for each surface, how much that it's going to be detailed or a little bit less detailed, so it either fit fairly closely to those contours or a little bit more loosely. It's taking time to think. So there. So you can see from that it basically took and understood what was going on with those contours. And with that command you can see we created a surface. In some cases it's not quite as tight to those contours. That's where you can increase the spans, say 200, well, let's say 150 because it might take too long. Maybe I'll bring up the stiffness, which I believe it means it'll tie to those the reference objects more. I'll bump that up to 20, and then I can hit preview. And it should get closer. after it's done thinking.
Run out of power.
Anyway, it should start to tie closer to those contours after it's done crunching the numbers. I guess it didn't. So it's kind of playing with some of these options though to see what you get. It might be a little bit more or less. Maybe I want it to be less stiff. I just started using this tool pretty recently, so I'm still kind of working through it. So that's one way you could start to create a surface. You could do the loft commands, or you could start working kind of globally with this. Obviously it takes a little bit of RAM power to kind of crunch this out. Other questions while this is still going there? I got a little bit better. Okay, why don't you guys start working through, bringing that poly surface, exporting it out of AutoCAD as an STL, bring that into 123D Make, start making some of those selections. We just have a few minutes left here, and start kind of understanding that workflow, especially how to understand the layout and so forth. The other thing, real quickly, that I forgot to mention that comes in handy. So if you are in 123D Make, you went through the process, you have all these pieces cut on the laser cutter, you can see here there's a toggle for assembly steps. So here are all the pieces, and you can see what part number it's on. This is just a little bit off, so basically what it's going to do, it's going to tell you what piece to start with. So we're on part Z3, and if we hit this, and we can kind of zoom around to see what it is, it's going to bring in the next piece, which is Y1, Y2. So basically it's giving you a recommendation about the steps and the sequence of pieces to put together that it thinks it's going to be the easiest for you. So as you know what they are, they're already etched with the number on them. You can grab that piece, put it in that location, and you can obviously zoom this around so you can understand a little bit better how to put this model together. So it's step-by-step assembly instructions, more or less. All right? Okay, so use the last 5 minutes or so to kind of start working through that workflow.